Have you ever wondered where gold, this shiny, precious metal that has captivated humanity for millennia, actually comes from? We see it in jewelry, in electronics, and even in our teeth. But its true origin story is far more spectacular and cosmic than you might imagine. It's a tale written in the stars, involving cataclysmic events millions of light years away. So forget everything you thought you knew about gold mines and panning and rivers. Today, we're going on an astronomical journey to uncover the real, explosive birthplaces of gold. To understand where gold comes from, we first need to understand how elements are made. The universe began with the Big Bang, which created the lightest elements: hydrogen, helium, and a tiny bit of lithium. All the other elements, including the carbon in our bodies, the oxygen we breathe, and the iron in our blood, were forged inside stars through a process called nuclear fusion. Stars are like giant cosmic factories. In their cores, immense pressure and heat squeeze lighter elements together to form heavier ones. A star like our Sun spends most of its life fusing hydrogen into helium. As stars get bigger and older, they can create heavier elements like carbon, nitrogen, and oxygen. But there's a limit. Even the most massive stars can only produce elements up to iron through fusion. The process of fusing elements to create iron actually releases energy, which is what keeps a star shining. However, creating elements heavier than iron, like gold, silver, and platinum, requires a massive input of energy. It doesn't release energy. It consumes it. So a star's core can't just keep fusing its way up the periodic table to gold. This creates what we call the iron peak. So if stars can't make gold through their normal life cycle, where does it come from? The answer lies in the dramatic and violent deaths of stars. For a long time, scientists believed that gold was created primarily during supernova explosions. A supernova is the spectacular end for a massive star, at least 8 times the mass of our Sun. When such a star runs out of fuel, its core collapses under its own gravity and then rebounds in a mind-bogglingly powerful explosion. This explosion is so energetic that it can outshine an entire galaxy for a short time. During this chaotic event, a flood of particles called neutrons bombards the existing atomic nuclei. This process, known as the rapid neutron capture process, was thought to be the key. Iron atoms and other elements would rapidly absorb these neutrons, becoming heavy and unstable. They would then undergo radioactive decay, transforming into stable, heavy elements like gold. For decades, supernovae were the leading theory for the cosmic origin of gold. However, as our models and observations improved, a problem emerged. While supernovae definitely produce some heavy elements, calculations showed they probably don't create enough gold and other precious metals to account for the amounts we see in the universe today. The conditions just weren't quite right to explain the abundance of the heaviest elements. Scientists needed to find another, even more extreme cosmic event, and they found it. Enter the kilonova. This is a phenomenon even more powerful and rare than a supernova. A kilonova happens when 2 incredibly dense objects, called neutron stars, spiral into each other and merge. What are neutron stars? They are the superdense remnants left behind after a massive star goes supernova. Imagine squeezing 1.5 times the mass of our Sun into a ball just about the size of a city, maybe 20 kilometers across. A single teaspoon of neutron star material would weigh billions of tons. When 2 of these celestial behemoths, locked in a gravitational dance, finally collide, the result is an explosion of epic proportions. The energy released is immense, and a huge amount of neutron-rich material is violently ejected into space. This material provides the perfect cosmic kitchen for cooking up gold. The conditions during a neutron-star merger are far more extreme than in a supernova. The density and temperature are off the charts, and there's an incredibly dense flood of neutrons. This is the ultimate environment for the R process to go into overdrive. Iron and other seed nuclei are bombarded with neutrons at an astonishing rate, creating the heaviest elements on the periodic table in mere seconds. It's in this spectacular, fleeting moment of cosmic violence that a significant portion of the universe's gold, platinum, and uranium is forged. The collision sends a brilliant flash of light across the cosmos and spews these newly created precious metals out into interstellar space. The scientific community got its first direct proof of this theory in 2017. Astronomers detected gravitational waves ripples in spacetime from 2 merging neutron stars located 130 million light-years away. Telescopes around the world quickly pointed to the source and observed the kilonova explosion that followed. By analyzing the light from this event, they found the distinct spectral signature of heavy elements, including gold and platinum. It was a groundbreaking discovery, confirming that these cosmic collisions are indeed major gold factories. Scientists estimated that this single merger event may have produced an amount of gold equivalent to several times the mass of the Earth. Just think about that for a second. One collision creating more gold than exists on our entire planet. So how did all this cosmic gold end up on Earth? After being forged in these kilonovae and supernova, the gold, along with other elements, traveled through space as clouds of dust and gas. Over billions of years, these clouds collapsed under gravity to form new stars and planetary systems. Our own solar system, including the Sun, Earth, and all the other planets, was formed from one such cloud about 4.6 billion years ago. This cloud was enriched with the heavy elements created by previous generations of stars and cosmic collisions. When the Earth first formed, it was a molten ball of rock. Because gold is very dense, most of it sank deep into the planet's core, along with other heavy metals like iron. This is why gold is so rare on the Earth's surface. The gold we find today in the Earth's crust and mantle, the gold we can actually mine, likely arrived later. During a period known as the Late Heavy Bombardment, about 4 billion years ago, the young Earth was pelted by asteroids and comets. These celestial visitors were remnants from the formation of the solar system, and they carried with them a fresh delivery of heavy elements, including gold. This gold was deposited onto the surface and mixed into the upper layers of the planet, where it remains today. From there, geological processes took over. Over millions of years, volcanic activity and hydrothermal fluids hot, mineral-rich water circulating through cracks in the Earth's crust dissolved the gold and concentrated it into veins of ore. Erosion from wind and water then broke down these rocks, releasing the gold. Because gold is heavy and doesn't corrode, it settled in riverbeds and streams, forming the placer deposits that triggered the great gold rushes of history. So every piece of gold, whether it's in a ring or a coin, has an incredible history. It was created in an explosive cosmic collision, traveled across the galaxy for billions of years, arrived on Earth via an asteroid, and was then concentrated by geological forces until it was discovered by humans. A story of gold is truly a story of the cosmos. It connects us to the most violent and energetic events in the universe. The very atoms in a simple gold ring were born in the heart of a kilonova, a collision of dead stars. It is a humbling reminder that the materials we value so much have an origin story more spectacular than any myth or legend. It's not just a shiny metal. It's a piece of stardust, a relic of an ancient cosmic explosion. So the next time you see a piece of gold, remember its incredible journey. It's a testament to the violent, creative, and interconnected nature of our universe. Thank you so much for joining me on this cosmic adventure today. If you found this journey as fascinating as I did, please hit that like button and subscribe to the channel for more explorations into the wonders of our universe. And don't forget to ring the notification bell so you won't miss our next video. Let me know in the comments what other cosmic mysteries you'd like us to explore. Thanks for watching, and see you next time.